Good day, learners. Welcome to physics lesson for today. In our topic today, we are going to be having current, electricity, and calculation. Moving ahead, we have a question to illustrate the objective of our lesson today, which says define the electric potential at a point in an electric field. B, state the relationship between resistivity and conductivity. C, a wire of length 2 meters and cross-sectional area 0.02 millimeters square has a resistance of 5 ohms. Calculate the conductivity of the wire. D, a circuit is as shown in the diagram below. Calculate the voltage V if I1 is 2 amperes. The circuit diagram represents question D. Okay, moving ahead from there, the first questions to be tackled, which says first question says that we should define the electric potential at a point in an electric circuit field, and the required response is electric potential at a point in electric field is defined as the work done in joules when 1 coulomb of electricity moves from one point to another. So that is what definition for electric potential is all about. Okay, the next question says we should state the relationship between resistivity and conductivity, and the required response to that is that the resistivity is the reciprocal of conductivity, or vice versa. That resistivity and conductivity are inversely proportional to the other. That is, one is the reciprocal of the other, as we have in the solution. So we have also that the symbol we have for this is pronounced as rho. Rho is equal to product of R and A divided by L, where R and A stand for resistance and cross-sectional area. That is the product of resistance and cross-sectional area divided by the length of the conductor that we are using. So that is what resistivity stands for. So in the same way, conductivity, which is given by mu is the inverse of what we have for resistivity, which is L over the product of resistance and cross-sectional area, or L over product of R and A. So that is what the relationship between resistivity and conductivity is stand for. So that is it. And next question says a wire of length 2 meters and cross-sectional area 0.02 millimeters square has a resistance of 5 ohms. Calculate the conductivity of the wire. Yeah, so for us to solve this, we have to write out this the terms or the parameters given to us. The first one is resistance is equal to 2 meters. Sorry, yes, the resistance or the length is equal to 2 meters, and cross-sectional area is equal to 0.02 millimeters square, and resistance is equal to 5 ohms. So we move ahead. By moving ahead, we have to first of all convert this cross-section area in millimeter square to meter square. We know that 1 meter is equal to 1,000 millimeter. So we are going to convert for easy calculation. We need to convert to millimeters square to meter square. So that means to convert 0 0.02 millimeter square will be divided by 1000 meters times 1 meter. This raised to power 2 and that raised to power 2, so that we have 0.02 millimeter square divided by 10 raised to power 6 millimeter square times 1 meter square. So this cancels this, so that we have 2 times 10 raised to power minus 8 meter square. So that is what length cross-sectional area stands for. That is equal to cross-sectional area A stands for in meter square. So we move ahead to find what we are asked to find. We are asked to find conductivity. Conductivity given by this symbol mu is equal to L over R times A. So substituting, we have 2 over 5 times 2 times 10 raised to power minus 8. So that's mu is equal to 2 cancels itself and cancel 2, and we have 1 over 5 times 10 raised to power 8, which will be equal to 0.2 times 10 raised to power 8, and that will give us actually 2 times 10 raised to power minus raised to power 7 raised to power 7 per ohms meter. So that's the unit and the value for conductivity we are asked to find. Is equal to that. So moving ahead, next question, which says a circuit is as shown in the diagram below. Calculate the conductivity V if I is 2 amperes. So parameters we are given, I1 to be equal to 2 amperes, and we have to find V, and R has to also be found. The effective value of R has to be found. So to find the effective value of R, we have to first of all, let's number it in this way. Let's call this R1, R2, R3 and R4. So R2 and R3 are connected in series. The same current passes through both of them, while R4 is connected in parallel with these two other that are connected in series. So this arm and that arm are in parallel connection. So while this will be, the R1 will be in series with, after evaluating all this, will be whatever we get from all this side will be in series with all of them. So the same current, the actual current flowing through this circuit is I, which passes through the R1. So when it passes through R1 and get to this junction, it's placed into I1 and I2, and I1 passes through R2 and R3, while R2 passes through R4. So let's now find the overall resistance in the circuit. We'll start by saying R S, which is the resistance in series connection between this R1 and R2, is equal to R2 plus R3, which is equal to 5 plus 15, and that gives us 20 ohms. So that is RS is 20 ohms. It's 20 ohms. So moving ahead, we have to find R in parallel. R parallel will be RS times R4 all over RS plus R4, and that will be equal to 20 times 5, 20 times 5 divided by 20 plus 5. So that R sub P is equal to 20 times 5 divided by 25. This cancels itself and this to give us 5. 5 cancels itself here and cancels this to give us 4. So we have 4 ohms. Now, having found that R sub P is 4 ohms, we now find R total. R total is actually in series connection. R total is in series connection. That is what we have found overall from here with this. So that will be equal to R1 plus RP, and that is equal to 5 plus 4, and that gives us 9 ohms. So 9 ohms is R total. Now, having found that, we proceed to find the overall current. We have to find the overall current, that is I, before we can find the potential difference V. But before we find I, we have already known I1, so we have to find I2. So to find I2, we have to find the potential difference across the parallel connection. The potential difference across the parallel connection is the same. Potential PD across the parallel connection is the same. Therefore, V, let's call it V, which is equal to V1 here. So V1 is equal to I1 times RS. Yes, I'm using RS this because we can find along this arm, which is part of the parallel connection with this, we have the current I1 is flowing through it. So the overall resistance along that part is 20, which is RS. We are going to use it to find V across the parallel connection. So that is why I'm doing this. So that would be V1 is equal to 2 times 20, and that gives us 40 volts. So 40 volts is what we have there. So now using this 40 volts, we go into finding I2. I2 then will be equal to V1 over R4, which is equal to 40 divided by 5. R4, which is this, is equal to 5. So that's what we have done, and that will give us, this cancels this to give us 8, so that I2 is equal to 8 amperes. Now moving ahead, we find I is equal to I1 plus I2, which is equal to I1 plus I2, which is equal to 2 plus 8, and that gives us 10 amperes. So having found 10 amperes as the overall current flowing through the circuit, the overall current through the circuit. So having found that, we now go ahead and find V, potential difference, or the voltage across the circuit will be I times R, total, if we want, according to Ohm's law. So that V is equal to 10 times 9. V is equal to 90 ohms. 90 volts is V. Thanks.